Greetings, my fellow Almontians, and welcome back to Remote Learning 2020. All right, yesterday we talked about air masses, right? These giant blobs of air moving around the Earth, and wherever they go, they influence the weather, right? If they're warm and humid, we called them maritime tropical. If they were cold and dry, we called them continental polar. And wherever they go, they bring those conditions with them. Well, there is, this blob of air, and where it moves, it has a front side. Well, they call that front side the fronts. And at the fronts is where you get all the crazy shifts in weather, right? That's where the transition zone is. They're kind of interfaces, to bring up another vocab word. And that's what we're going to focus on today. The fronts of the air masses, we just call them fronts. Okay? All right, so let's jump into it. We're going to start out with a little weather report. This is from a little while ago, but it doesn't matter. The pictures and the animations that he used are very good for checking out fronts. So check out our previous forecast here.
All right, shifting gears now to the forecast. We are warming up for the weekend.
Oh, yeah.
Good news.
Finally, Amber, it'll feel more like spring. We deserve it. I mean, especially after these frigid temperatures that we've had to deal with. Satellite and radar picking up plenty of clouds. Here's the reason why. We have that high pressure system that's been keeping us dry and cloud free. That's actually moving on out. We have southeasterly winds also bringing in some moisture. Let's take a look now at those highs. For your Thursday, we'll switch gears. Here we have it, 33. This is about a 20-degree difference from hump day, let me tell you. And we should be at around 45 this time of year. 19 degrees for the early morning lows, and of course the overnight is a little bit less cold, if you want to call it that. 21 for Neck as well as Kingsbridge, but East Tremont coming in at about 24. Still feeling like the teens though, so keep that in mind. It's going to be very, very chilly out there. Chilly right through Friday. Clouds will prevent temperatures from really climbing up, so hence about 41. That'll be the average there in Pelham Parkway and Parkchester. Chilly conditions for your Friday. Here's a look at our surface map. Cold temperatures. We're going to eventually get rid of that. Winds out of the north, switching gears to be coming more southeasterly. That cold front will bring in some rain. Cooler temperatures, though. Now, we do have a shot of rain now Friday night into Saturday, but a greater chance of rain Sunday into Monday.
So take a closer look at that front moving in there. It looked like, let me go back to it there 1 second. Well, I'll show you in a second. But when that cold front moves in, you notice there was like this green blob around it, because it usually rains at the fronts, and those green blobs meant rain, and the weather will change, will transition as that front goes through. All right, and we'll look closely at other pictures in a second. Read this through. This is how you define fronts. Make sure you read that through thoroughly. Okay. As your formal definition, right, that boundary between two air masses meet at the fronts. The actual term came from that's like a military history from World War I believe, where somebody observing the battles realized that all of the confrontation and the heavy firing and all that stuff all occurred where the fronts of the armies met. Hence, it was related to weather. All of the crazy weather, the action, the lightning, the storms, all that stuff occurs where the air masses meet at their fronts. That's where that term came from. It's unstable air. It's going to be rising air, always low pressure, because when you have a storm, it's low pressure. Okay? These are the fronts. You don't have to memorize them, but you probably will. These are in the reference tables. They're in black and white, of course, but the color is not important. It's the symbol, right? That's your cold front. That's your warm front. Okay? And the others, of course, you should know as well, occluded and stationary. All right? It all depends on the symbol and what side of the line it's on. It'll tell you also which direction it's moving. So you see how this is on this side of the line? Well, that would be moving that way. Okay? We're going to start with the cold front initially. You'll notice the triangles on the ground there, right? That's your cold front symbol. And it's advancing this way. Well, that makes warm air rise. When air rises, it cools and condenses. You start to make clouds, and eventually you get a big storm. Now, you might recognize that shaped cloud there. That's that big cumulonimbus cloud, right? So this is a cold front because the cold air is advancing, and it makes that warm air go up and creates, of course, low pressure. So why is the cold air pushing up the warm air? Well, warm air is less dense. Okay. As a result, you get crazy cloud formation and big storms. Okay. That's your classic cold front. Fast-moving cold air pushes up warm air, and you get stormy, low-pressure conditions. Tornadoes are brought in by cold fronts, right? Those vicious storms are brought in by cold fronts. Okay. So let's take a closer look. You have cold temperatures on one side of the line and warmer on the other. Well, a front will separate those temperatures, and the colder temperatures would be a colder air mass, right? So we'll call that like a polar air mass, if you will. The warmer ones would be more tropical, all right? You're going to put your front symbol just like that because the cold air must be advancing into the warm air, right? If it's a cold front, it's advancing. Behind it, it already made cold. In front of it, it's still warm, all right? There's your air masses, right? Your continental polar behind it, and in front of it, well, why not put a maritime tropical, right? A nice warm air mass, all right? It's going this way because the symbols are on that side of the line. All right. Well, before a cold front gets to Elmont, it's going to be warm, right? Before it gets to any place, it's going to be warm. The pressure will be relatively stable, right? There will be no storm until it gets there. You might have some clouds, you might not. This is before the front gets there. And generally, you're not going to have any precipitation until it gets there. Well, at the front, things start to change, right? Your temperatures will start to get cooler. Your pressure, of course, if there's a storm, it'll drop quickly. You'll get big cloud formation, right? Those cumulonimbus clouds will form, and you'll get heavy rains, right? Could be hail, could be severe lightning, potential tornado if it's coming fast enough and the other conditions are correct. After it passes, though, it's like the calm. It just kind of dies out. The temperature goes way down, and of course that brings your pressure way up. The cloud cover will dissipate, right? Because once the pressure goes up, high is dry and cool, right? That should make sense to you. And the rain will taper off to nothing. Okay? So make sure that chart makes sense to you. It's kind of a flow, right? This is before it gets there. This is when it gets to your town, and this is after it passes. And you just kind of have to envision this advancing through. And this is a side profile. Right, so on the ground would be your triangular symbols coming this way. All right, that's your cold front. A warm front now is not as dramatic. It's a lot slower. Take a look. There's your warm front symbol on the ground. It is trying to advance, but it's very slow. Because warm air is less dense, it'll still rise up as it advances. And you get these big, broad clouds. You will start to get, of course, rain before the front actually gets there. It generally won't be the heavy rain. It could be, but usually not, because it's moving very slowly. And that's a classic warm front scenario. Okay? Why does the warm air rise? Once again, warm air is less dense, right? Identify what forms ahead of this warm front. Take a look. You have cloud formation ahead of the front. So if you're standing here, you'll notice the clouds start to get lower and lower as the warm front advances. And that's a telltale sign that you got a warm front coming. It's not a cumulonimbus cloud. It's just a cloud base that gets lower and lower, and then the gentle romantic rain starts. And you know you got a warm front coming your way. Okay? There's your official definition of the warm front, slow-moving warm air mass. And as it hits the cool air, it rises slowly above it as it advances. Okay. And the chart, once again, so here we go. Now we have warmer temperatures on this side, colder on this side. It must be going this way, because if it's a warm front, it's warm air advancing. All right? So you put your symbol on the line. It should be the semicircles going that way. Behind the warm front is warm air. It's a tropical air mass, right? So we'll put an MT back there. Also could be a CT, but we'll leave it at MT for now. And in front of it's got to be a cold air mass, a polar air mass, so we'll make it a CP. Here we go. Before it passes, well, it's not, the warm front hasn't come yet, so your temperatures are going to be cooler, okay, relative to the season, of course. The pressure, well, it's higher because it's cooler air, all right? Cloud cover, remember the clouds will start to form. They'll be high at first, those cirrus are the high ones, and they'll start to get lower as it gets closer to you. And you'll start to get light showers, gentle romantic rain, okay? When the front gets there, well, your temperatures will, of course, start to warm up. Your pressure will continue to drop, right? It's warm air. Warm air is less dense. Rising air makes lower pressures. These are the type of clouds that you'll get. It'll kind of be just a totally dark sky. And, of course, you'll get rain or drizzle. You generally don't get the thunderstorms with a warm front. It's possible, but generally not. All right? After it passes, well, of course, it's going to start to get warm. In the summer, it'll start to get real warm. The pressures will stay pretty low because warm air, again, less dense, rising air, low pressures. You'll have scattered clouds. The rain will start to dissipate, though. The rain will start to go away as the front moves on. All right, and that's a classic warm front scenario. All right. The other two, the stationary and the occluded up top, take a look. You got the semicircle on one side, triangle on the other. That's a stationary front. As long as it's not moving, it's stationary. As soon as it starts to advance, if the cold air starts to advance, it'll turn into a cold front. If the warm air starts to advance, it'll turn into a warm front. But if it is not advancing, it's just kind of stuck there, it's stationary, and you put the symbols on opposite sides of the lines. Okay? The occluded front is when you have very cold air bumps into cool air and the warm air gets stuck on top because it's the least dense. This can bring periods of long periods of rain, several days. This one tends to be on and off rain for several days. This one just kind of tends to be constant rain for quite a while. Okay? All right. So what you guys got to do is, looking at these pictures, you got to name each front based on the evidence, the clues in the pictures. And then, of course, you have some summary questions that follow, and we'll go through that in the meet. All right? See you there.